So we're in the section of solving radical equations. Radical equations mean expression with roots. That's for radicals. So what I mean by roots? Square roots, cube roots, fourth root, fifth root, and so on. And equal sign. That's what equation is for. So when you see the word or the term radical equation, it's an expression that has roots and then it has an equal sign. So the equal sign is for equation, roots is for radical. Now, when it's solving for radical equations, your first job is try to isolate the variable. Try to get it by itself. Once it's by itself, apply the root according to the exponent. So for example, if x is square, you would apply square root. If x is cubed to the third power, you apply the cube root or the third root. If x is to the fourth power, then you would apply the fourth root. So let's work on our first example. So say you have x squared plus 24 equal, say, 40. Alright, so what you want to do is isolate the variable by itself. So on the left side we have x squared plus 24. If I want to get x squared by itself, I want to get rid of the 24. So the opposite of plus 24 is minus 24. Since I did it on the left side, I have to do it on the right side. So I'll bring down the x squared, the equal sign. 40 minus 24 is 16. Alright, I'm going to bring it to the side. So what we have is x squared equal 16. Next, if I want to get rid of square, I apply the root. So apply the root according to the exponent. So since it's square, I'm going to apply the square root on the x because I just want x. So since I apply the root on the left side, I gotta apply the root on the right side. So doing so, the square root of x squared is simply x equal, since I'm doing the square root of 16, the square root of 16 is 4. But remember, it's a positive square root. Whenever you do a square root, you have to include plus and negative, or plus and minus, of the number. So the square root of 16 is positive and negative 4. And if I were to plug positive 4 in, positive 4 square means positive 4 times positive 4, which is positive 16. If I were to include negative 4 into x, it would be negative 4 times negative 4, which is also positive 16. So those two answers works. So the final answer for this equation is x equals positive and negative 4. Now in our second example, we have 2x squared plus 10 equals 42. So again, we want to get x squared by itself, isolate the variable. So that means even though I want to get x squared by itself, I technically need to get 2x squared by itself. So I need to get rid of the 10. The opposite of plus 10 is minus 10. Since I did it on the left, I gotta do it on the right. So what I'm left with on the left is 2x squared equal 42 minus 10 is 32. Alright. Since I got 2x squared by itself equals to 32, now I just want to get x squared by itself. So what I'm going to do is first I need to get rid of the 2. Now since it's 2x squared, and it's multiplying, I'm going to divide by 2 and divide by 2. So doing so, 2x squared divided by 2, the 2 and the 2 will divide, and I'm left with x squared equal, and 32 divided by 2 is 16. So we got x squared by itself, and it's equal to 16. So just like in the last example, so x squared equal 16. Next, if I want to get x truly by itself, I have to apply the root. So that way the square can go away. So the opposite of square is square root. So I'm going to apply square root on the left and apply square root on the right. Doing so, the square root of x squared is just simply x. And again, the square root of 16 is positive and negative 4. And if you want to check if your solution is correct, just simply plug in positive 4 into x and negative 4 into x. And our final answer for example 2 is x equals positive and negative 4. Now in our third example, we have negative 4x squared plus 15 equals 51. So again, isolate the variable. We want to get x squared by itself. So technically we need to get negative 4x squared by itself. I need to get rid of the plus 15. Opposite of plus 15 is minus 15. Since I did it on the left, I got to do it on the right. So I'll bring down the negative 4x squared equal sign. 51 minus 15 will be 36. Alright, so now we got negative 4x squared by itself. Now I want to get x squared by itself, so that means I need to get rid of the negative 4. Since it's multiplying, I'm going to divide by negative 4. Since I did it on the left, I got to do it on the right. Divide by negative 4. So negative 4 divided by negative 4 will be 1. I'm left with x squared equal 36 divided by negative 4. That's going to become a negative 9. Remember, positive divided by negative will become a negative. So I'm going to bring it over here. We have x squared equal negative 9. Now, I want to get x to be by itself, so I need to get rid of the square. So I'm going to do the opposite of square, which is square root. Do it on the left, do it on the right. So doing the square root of x squared again will be just x equal. Now here's the situation. We're doing the square root of a negative number. So when you have a negative number, it won't be a real solution. It's going to be a complex solution or imaginary. So the process is I need to separate the negative. So I'm going to break it into two factors. Negative 1 times 9 inside the square root. Then I separate it as two square roots. So now it's negative 1 inside a square root times a positive 9 inside another square root. So when we have that, the square root of negative 1 is simply changed to I, multiplication, and then the square root of 9 will be, since we're doing a square root and it's a perfect square number, the 9 is going to be positive and negative 3. So I times positive and negative 3, therefore x will equal to positive negative 3I. So that's going to be our solution. So the answer to negative 4x squared plus 15 equals 51 is x equals positive negative 3i. And we only have I because we did the square root of a negative 9. So when there's a negative inside a square root, then that for sure you'll see you will have an imaginary number, or I. So in our fourth example, we have x to the third power minus 2 equals negative 66. So I want to get x to the third by itself. I need to get rid of minus 2. So the opposite of minus 2 is plus 2. So add 2 on the left, therefore add 2 on the right. Now I have x to the third equal negative 66 plus 2 is negative 64. Alright, I'm going to bring it to the side to make it look neater. So x to the third equal negative 64. So I got x to the third by itself. Now next I want to get x to be by itself. I need to get rid of the exponent. So the opposite of the third, or cube, I'm going to do the cube root or the third root. Since I did it on the left, I'm going to do it on the right. So that's a cube root or the third root. Now, it's similar to the last example. We have a negative number inside the root. Now, if it's a negative number inside a square root, then you will have imaginary numbers. If it's a negative number inside a cube root, then there's a possibility that your answer can be negative. So the third root of negative 64, basically, if I were to talk about the concept, it's asking what number times itself 3 times that will give you negative 64. Well, if you were to think about it and you're not sure, well, you can do is try 1 to the third power. So if you do 1 times 1 times 1, that's just simply 1. If you try 2 to the third power, simply is 2 times 2 times 2, and that's going to be 8. Now if you were to do 3 to the third power, so 3 times 3 times 3, multiplying all of them together, 3 times 3 is 9, then times 3 again is 27, still not 64. So let's try 4 to the third power. So 4 times 4 times 4. So 4 times 4 is 16, then 16 times 4 again, that would be 64. Okay, so it's going to be 4, but here's the situation. If it's 4 to the third, it's positive 64, but we want negative 64. Well, what happened, instead of positive 4, what happened if we use negative 4? So let's try that. So if I do negative 4 in parentheses to the third power, so basically negative 4 times negative 4 times negative 4. So negative 4 times negative 4 is positive 16, and we're going to multiply by negative 4 again, which would be negative 64. Alright, so it could be negative 4 then. As shown here, negative 4 to the third power will equal to negative 64. So let's continue with our work. Continuing from the work above, the cube root of x to the third will be simply x equal. The cube root of negative 64 will be negative 4. So x by itself, and it equals to negative 4. So that's our final answer. So in this example, x to the third minus 2 equals negative 66. Our final answer is x equals negative 4. Now in example 5, we have 3x squared plus 11 equals 71. So if I want to get 3x squared by itself, I need to get rid of the positive 11. So the opposite of plus 11, positive 11, will be minus 11. Do it on the left, so I gotta do it on the right. So we're gonna have is 3x squared equal 71 minus 11 will be 60. And then since we have 3x squared and I just want to get x squared by itself, I need to get rid of 3. So the opposite of multiplying is divide. So I'm going to divide by 3. Do it on the left, I got to do it on the right. So the 3's will divide into 1, and I'm left with x squared. And then 60 divided by 3 is 20. Alright, let me bring it to the side. X squared equals 20. Since it's x squared and I want to get x by itself, I need to get rid of the square. So the opposite of square is square root. Do it on the left, I gotta do it on the right. Now, the square root of x squared will again be x. But here's the situation, 20 is not a perfect square number. So I can't just simply square root this right away. Now, what we can do is break it down into two factors where one of them is a perfect square number. A factor for 20 that we can use, and it's a perfect square number, would be 4. So I'm going to break it into two factors, 4 times 5. Inside the square root, 4 is a perfect square number, so that's good. Once I broke it down into two factors, I'm going to break it into two square roots. So we're going to have the square root of 4 times the square root of 5. And then moving on forward, I can simplify the square root of 4, which is 2. And since it's the square root of 4, it's going to be positive negative 2 times, I can't break down 5 into any other factors besides 1. I can't simplify it, so I'm going to keep the square root of 5 and bring it down. So if I were to combine, positive negative 2 times square root of 5 would be simply positive negative 2 square root of 5. So that's x. So the example 3x squared plus 11 equals 71. Our final answer is x equals positive negative 2 square root of 5. So in this example, we didn't get a perfect square number, so we ended up with positive negative 2 square root of 5 with a radical in our final solution.